Hello, and thank you for attending this presentation on scaling sustainable innovation through team autonomy. And that kind of immediately may come across as super academic and somewhat complex, and there's some buzzwords maybe in there or somewhere embedded in there or something. But really, it's just a formal way of saying, like, we live in a super cool time to be working on software. And I think it really, we owe it to ourselves to really think about how can we take this profession and this industry and move it forward. So that being said, quick introduction. Who's this guy talking in front of you here? My name is Tom Stoepker. I'm currently a senior software engineer at bol.com in the Netherlands. And my current day-to-day tasks are pretty much involved with playing around in the cloud or being serious in the cloud and using it to serve product media for bol.com products. You can find me around the usual haunts on the internet. I'm out there at GitHub, Stack Overflow, and a static website out there at tomstoepker.info. Great, so let's kind of dive into this, but before we do, I just want to give a disclaimer. We have some buzzwords ahead here. So we have agile, we have Scrum, DevOps, fail fast, iterate. You know, under themselves, these are all super compelling ways of working. There's nothing intrinsically necessarily wrong with them, but at a certain scale, and that scale might just be, you know, me bringing on a good buddy to work on open source, and now we, you know, can't work together, or at a large scale company like bol.com, things can get a little weird. Take agile for example. Just with a slight shift, we have fragile. Take Scrum. You know, just with a little bit of jumbling, something not going super right, it just kind of falls to crumbs. We have DevOps, and before you know it, we're making dev flops. And iterate, you know, we're effectively obliterating things in quick succession. So super interesting ways of working. Oh, wait, fail fast, of course, let's do that. But really, that just sometimes just amounts to pure failure. So then what? What can we do to move ourselves forward in a sustainable way? And so when I ask these questions, I always, of course, turn to Twitter. This tweet here has had some shelf life. I think JBD, she works on the Google Cloud team, posted this in 2017. But I found this one pretty interesting. Don't blindly apply dogmatic advice. Use your judgment each and every time. And I read that and I was like, oh, cool, totally. That's like some super meta advice that's like doing some kind of recursive advice about not giving advice, and that's super deep. And then I was like, I don't even know what dogmatic means, so let's look that up. And I guess it means, or the first thing that pops up when you type it in, inclined to lay down principles as undeniably true. So instead of looking at like all these ways of working and blah, 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 let's just shift our focus maybe on something that's subjective. And that thing that maybe we want to focus on is building software that users can trust, and as the benefit of the one working on it, have that software perform in a way that enables me to get a little bit of sleep occasionally. Now, can Agile enable this for our team? Can DevOps enable this for our team? Can Scrum? Can maybe failing fast? I don't know, maybe, possibly. For you, it very well may be like the silver bullet, if there is such a thing. But I think, again, we need to really think about our engineering and business decisions a little differently. And kind of getting into the theme of this presentation is what we are building sustainable. So let's get started. Quick shout out to Uncle Bob, of course. So what are we talking about here? What is sustainable innovation? We'll kind of dive into that in a little bit more detail. What sustainable innovation and approach to sustainable innovation looks at bol.com. And then the kind of key ingredient which in bol.com's case is team autonomy, and we'll kind of distill that out at actually a technical level as well. So sustainable innovation. This is the current definition that I'm running with. Feel free to issue a merge request to improve it. But creating or improving a core value proposition without regression in a way that is maintainable in the context of dynamic and ever-changing business requirements. And we do live in this age, especially if you're working on network product software. It's like features, requirements, changes, rollout, we got to hit this, Christmas is coming, whoa. So how can we develop software knowing that that is the business reality, and maybe improving the business reality, but of course I'm just an engineer, but knowing that that is the business reality and writing software that we can roll out with confidence. So some questions you may ask yourself when you're thinking about this notion of sustainable innovation. Is there any risk in developing a feature? And once it's shipped, how will it be maintained? Is the value proposition of the feature in line with our business model? And does the value proposition of the engineering decision improve how the product is used? And when we get to the engineering level of this decision making, I think the concept of innovation sometimes becomes a little blurry because, you know, I'm wearing my coder hat, I'm back there, I'm looking at all the coolest stuff, I want to make things run fast, I want to run everything in parallel. But really, I'm just another employee at a business that's trying to create something valuable for its users. So I think as an engineer, it's important, especially this day and age, for, you know, realizing that technology itself, or maybe for your business, isn't necessarily innovative, but a highly potent enabler for what your business is delivering. And of course, chasing the hype. You know, this is a common theme, the traps. To be honest, all of this tech is super cool and like made by much greater minds than myself, and it's all just super awesome stuff. And the reality is, it's super cool, but it also isn't necessarily great for your business model. So, but what it is always good for are GitHub stars and Stack Overflow points. But I digress. So getting back to sustainable innovation, you know, those things are not necessarily off the table as tools. They're just, I think we should look at them as tools as engineers when we're looking to move our product forward. But it's not just always about engineering. So how can this scale? How can this scale from a technical perspective? How can this scale from a people perspective? You know, that question, you know, that happens in every talk about what's happening with technology. How can this scale? Well, I may have some thoughts on a potential answer here. But of course, I don't just want to come up with stuff. I want to use the context of working with my current employer at Bol.com as a case study. So real quick, who is Bol.com? If you aren't familiar, they're currently one of the largest online marketplaces in the Benelux region. Started in 1999, with just a handful of employees, and has now scaled to over 1,800, offering 21 million products. Some pretty cool evolution there if you think about it. This is a kind of a super cool overview of the type of growth that the company has seen, starting from just books and now evolving to what we're working on, scaling it into a full-fledged retail platform. From a technology perspective, the company started out from just shipping monthly monolithic applications via third parties and has now evolved into DevOps-driven, service-oriented architecture. A lot of buzzwords there, but very interesting that a company starting in '99 has evolved and stayed fresh in that sense. So in summary, who is Bol.com? A company who has sustainably grown their business while maintaining an innovative and competitive edge. But what is kind of the underlying, okay, cool, we're talking about sustainable innovation. What are things that we can actually do to enable this concept? And a company that actually got its start before, you know, all the buzzword companies that we reference as the great tech giants of today, like Facebook, Twitter, and so on and so forth. And that secret ingredient, well, maybe not super secret, because I think a lot of you are familiar with this concept, but it's a concept that's thrown around a lot and manifests itself in different ways, but is team autonomy. And what do I mean about team autonomy in the context of this conversation? And that is that teams at Bol.com, their ways of working, their roadmaps, even their kind of within their bubble, their internal organizational structure, the technology choices they make, even decisions around how to onboard, who to hire, who to kick out, so to speak. And product implementation details are all fundamentally determined at the team level. But now this kind of sounds like, okay, wait, couldn't this create some kind of fragmentation? How does this impact being able to sustainably innovate? And from my experience in the industry, one of the success of great technology companies are built upon the thousands of micro decisions we make as engineers a day. I mean, how many lines of code are you working on a day? How many things will have critical impact? Maybe not now, but in the long run, when certain scenarios occur. So on and so forth. That's a very tough model to manage, and thus managing all of these micro decisions becomes quite difficult, maybe even impossible. And if it were possible, could potentially stifle ingenuity that can facilitate a competitive edge. So let's look at this hypothetical dependency graph in terms of teams. And this is maybe more of a traditional model. What this is trying to illustrate here is we have our C-suite at the top. middle management, maybe you know, our server provisioning management folks in the middle, and then of course us lowly developers at the bottom. And the arrows are pointing up because decisions and actions and progress moving forward on a product is completely dependent upon some kind of chain of command from above. What team autonomy effectively does is, well, maybe at first glance make things look more complex, but actually what it does is it frees up the dependency model. So now each team, and then at Bull.com we're even more explicitly moving towards a product-oriented structure, but each team effectively manages a product. And so when a larger initiative comes into play, the dependencies become more organic. Instead of teams now just waiting because, you know, manager 5A rank 23C, you know, with experience of N years with a PhD and whatever, you know, now have, okay, I work on media. You work on products. Okay, cool. We have to now have a way for our data science people to do stuff. And collaboration then becomes more organic because we have teams that are focused on a domain. And when larger initiatives come into play, they have to organically kind of collaborate. Now this all sounds great, so what is really kind of the secret behind making this work? And that's really a common culture and goal, and so I kind of, you know, have illustrated this by wrapping this dependency graph here in this cool blue bubble. And this blue bubble is actually quite critical, because if teams obviously don't have a certain roadmap, a certain goal, ours at Bull.com now is to really be the best retail platform in the Benelux region and beyond. Well, you know, what are we focusing on? How can these organic dependencies manifest themselves? And that is a tricky part, and that's something that that Bull.com has done quite well, and I think a lot of other companies that have seen this model be successful for them, there's a common vision. Even though I may not work on your team, we have an understanding of the general direction we're going in, and it's a model that as a company scales to 10 million customers and all of the moving pieces underneath it, the ability for teams to focus on their micro problem and then plugging into the larger picture becomes, well, more scalable and ultimately more sustainable. So that blue bubble, what can that be summarized as? In Bull.com's case, it's a culture where the customer is first. And this is like age old, but it's really, really true, and it's super cool. And even though it's like super cliche, the customer is first, it's like really the coolest thing about business. If your customer is really being put on a metaphorical pedestal, you know, they are attracted to your product. And at Bull.com focuses not only on the customer, but the partners that sell on the platform as well. So great. You know, the engineering minds are here. I'm like, okay, this dude's on another way of working, rants, blah, blah, blah. But the thing is, it does all sound good in theory, but how can we actualize it from an engineering perspective? This is one thing that's a challenge. So let's now take this whole kind of macro concept of team autonomy at Bull.com and zero in on a single team. And that's the team I currently work for, Team Mirage. Shout out to Rokier Lummers. What does Team Mirage do? We work on all the product media that is, and actually multimedia that Bull.com displays on its websites and mobile applications. We deal with 15 million assets coming in a day. So assets in this case are predominantly images, pictures, but also could be PDFs or audio, or we're now starting to scale our video platform. So we should see this number get even more interesting. For our web client-facing applications, we have to maintain APIs that serve at peak 20,000 requests per second at around a 25 millisecond 90th percentile response time. Internally, our systems now are generating over 1 billion events per month, so we now have this whole cool new visibility into what's happening. People who are sending, you know, their Teletubbies in can now see when it was sliced and diced, so on and so forth. And we're doing this with one product owner and 4 engineers. So how can a small team sustainably innovate? So we take this picture, okay, great, we've been given the gift of team autonomy, and we have this tall order to fill. So how can we move our product forward, the product media, and stay innovative, keep the business in such a position where if things need to change in the future, we can rise to the challenge. And of course, the key ingredient here is we should all be able to take a little bit of vacation time while being able to do this. So the goal in Team Mirage has been to effectively, our kind of design principle and how to maintain this has been to reduce the cognitive load and time commitment to maintaining, provisioning, and running software, and ideally enable focus on writing it. So of course, bam, there it is. You knew it was coming. How do we enable this? Well, of course, you got to automate things. So let's get to it. So we're going to dive into what kind of an example setup. It's more, pardon some of the trivial nature of some of the setup that we're about to dive into, but it's more to kind of illustrate concepts that I'm sure you're all familiar with, but I think concepts that get overshadowed by the hype and I think are quite important and have been important for Team Mirage. So we look at setting up CI/CD. And what we have here is some code. It goes into GitLab, which is represented by the GitLab logo there in the gray circle. GitLab then uses runners, which then orchestrate our ability to automate testing, building, and deployments. So let's hop into what looking at setting up a testing environment might look like. And we're going to start greenfield. I can smell the no code. It's awesome. Great. So we're going to call this project Textify because it is the coolest thing ever. And of course, you need an if-I if you're starting anything that does things. And we, of course, want to initialize it with a README because READMEs don't undervalue the epic importance of good documentation. And we got some stuff here about auto DevOps, so on and so forth. But let's just really dive in. So we'll clone the project and fire this thing up. Cool, empty project, just a README. Excellent. Let's get started. So as any good Git citizens, we should set our project up with a git ignore. And you may be asking, what's this little snippet thing to try to fast track some of the super obvious stuff of this presentation? I have a little generator. Cool. And we're going to do this demo in Go just because of the simplicity of the tool chain. So we'll initialize a package. Cool. Not too much stuff interesting. We're still focused on where are we here. Let's reorganize our slides for optimal swiping efficiency. Yes, testing. Great. So let's make a package, and let's call it say. And in this package, you guessed it, we should probably say hi. Cool. We'll declare this package as say, and add an awesome function, user. Could be a name, something. And of course, returns the quite predictable hello to the user. Great. And of course, being a good Go citizen, we'll document hello returns something obvious here. Not to trivialize the importance of documentation, but for the sake of the presentation. Cool, but back to the goal, we need to get some tests happening. So we'll set up a test, awesome, test case. And we'll have some simple args. In this case, we'll just, you know it. And what do we want? Exactly. Cool. Fix that syntax error. Great. We can see the test VS Code is already telling me that they're doing their thing. We can just run them as a sanity check. Oh, tests are failing. Hey, check it out. Ah, thank you. And actually, now that you bring that up, it might be a good feature enhancement. Boom. Tests are passing. Cool. But now back to the getting. What are we focusing on here? Sustainable innovation. Okay, we wrote some tests. Let's add this stuff. Add some testable code. Great. And let's fire this back up to GitLab. Awesome. Head over to our CI/CD pipelines. I'm excited. What do we got going on? We got a spinning. Oh, we're stuck. Okay, what's going on here? Of course, yes. If we step into our build, we can see that we need some runners. And if we go back to the presentation, that's the tool that will orchestrate our build pipelines. So let's quickly turn off this auto DevOps whateverness. That's actually kind of cool. I don't mean to, sorry GitLab, it's a super dope feature, but we're going to do stuff ourselves this time around. And we're going to pull up a runner. Cool. What effectively I have back here is GitLab and the runner is running in a Docker environment. And to spare the details, I just have a simple script that will enable us to quickly register a runner. We'll give GitLab a kick. And what do we got? Great. A runner. Back out to our pipeline. Cool. Now it's running the stuff that GitLab had configured for us before, so we need to actually give it some work. So if you may be familiar with GitLab, if you may not, hopefully you're familiar with YAML. And in the 21st century, it's amazing. Like, you got to be a full-stack YAML developer or something. Everything's in YAML these days. It's so cool. Or not. Whatever. Awesome. So GitLab, CI, YAML file, and of course, not to blame the Mac, just blame my own fingers, but yeah, we still have some sticky keys here. Cool, so awesome, blank YAML file, this is so cool. What are we going to tell GitLab to do with this thing? We're going to tell it that we need a base image. We have dependencies for our build time. In this case, it's quite simple. We just have Go and some other things. So I've prepared a simple Go builder that we'll use, that will execute in all of our pipelines. Now this is overrideable. But we'll save some of the details for the documentation. Cool, so what's next? We need to define the stages of our pipeline. And of course, we need to set up a test, and then we need to give it some work. So our first job will be a unit test. It will be assigned to our stage test. And the script that will run will just simply invoke the Go test tool. Awesome, looks good. Let's add all that. Commit it. Task, add testing to our pipeline. Great. Push that up. Head back over to GitLab. Let's see what we got. Alrighty. GitLab CI. Huh. Excellent. No tests are running. Add testable code.
It's a dot file edit.
Oh, thank you. It is, very much so. Great. We'll fix that, and of course, use fix our GitLab file. Great. Fire that up, and now see what we got happening. Cool. Our tests have spun up. Awesome. So we can watch the logs. I'm sure they're incredibly interesting, but in reality, they just pull down the Docker image that I've specified. They clone the Git repository within the context of the GitLab runner, and then execute our tests. Awesome. Testing. How does this impact sustainable innovation? Well, it allows us to improve the product with confidence. It enables, if teams are testing with diligence, it reduces the possibility of regression. Another cool side effect of this is it enables us to onboard new engineers with confidence. So scaling from a personnel perspective. If our code coverage is tested well and also in such a state where it cannot cause us business harm if it were to fail, new engineers can come on, start working, and be able to make changes with confidence that anything that will cause failures will be caught in our pipeline. And then, of course, all of the other benefits of testing, which I'm sure you guys are familiar with, and there are lots of other great resources in diving into that topic. Awesome. So we got some testable code, but it's kind of useless, so let's build something. But before we do, we're going to take a quick pause in your regularly scheduled programming and give a shout out to semantic versioning. And semantic versioning not just by itself, but with conventional commits and a little tool we call Versioner. So you're like, wait a second, we're just looking at GitLab pipelines, we're talking about sustainable innovation, now we're talking about semantic versioning. How does this all come into play? And that is this question that I don't know if you've had working in some software projects I've had. It's like, what are we working on? Oh, yes, we're working on version FF9387.123-923.12.12. Awesome, cool. Okay. Wait a second, is that compatible with QQ11134-alpha- if you've had these experiences, let's just try to cut them out. And that's what semantic versioning, and it's a versioning scheme that I'm sure most of you are familiar with. But if you aren't, it's pretty cool. It's quite simple. That's the cool part about it. And effectively boils down to you have a major, minor, and patch version. Your major is incremented when the software you release introduces a breaking change. Your minor version is bumped when you add functionality in such a way that is backwards compatible. And then your patch version when you're making the little tweaks, bug fixes, so on and so forth. What are conventional commits? Maybe something that is less familiar, but it's effectively a standard for how to write commit messages. And it sounds quite boring and dry, and you'd be kind of correct in saying that, but I think it's super cool. Some examples are you have some prefixes in parentheses. It almost looks like a function call with the argument being lang in there and the return type being some kind of fluent string. But in this case, it's just saying we have a feature for the language portion of our application, and what are we doing? We're adding the Polish language. If we introduce a breaking change, we add that breaking change in the footer of the commit message. How does this affect semantic versioning then? When a breaking change is introduced in the commit message, we bump our major. When a feature is introduced, we bump our minor, and task fixes and maybe other prefixes that your team likes to use, we bump our patch version. And oftentimes when I talk about, oh yeah, conventional commits, we're using this in Team Mirage, new developers are like, oh man, are you serious, dude? Like, why are we doing this stuff with commit messages? I already have to like write Go and like write Java and do all this stuff. Like, why do I have to think about commit messages? And it goes back to then this principle of sustainable innovation, because we now can automate meaningful versions. And developers can just focus on committing code. We take conventional commits, semantic versioning, and a tool that we put together called Versioner, and we're able to achieve that. So let's take a quick look at what that something might look like. Great. So we're back to our awesome Textify application. And the first thing we want to do is, okay, we know we're about to deal with versions, so let's make sure the app has a home for that version. So let's make a package called diagnostic, and in that package, we will add a version.go. In this version.go file, we simply add an app version. And we will just default it to dev mode. Awesome. Of course, we need the package. Great. Now, we have this app version, but what are we going to do with it? My handy dandy snippet generator has a make file on the back burner here, so let's spit that out. Again, if you're not familiar with Make, maybe you are. Super cool tool to kind of normalize build processes and even the language within your team in terms of how you execute stuff that's for your setup. In this case, don't worry too much about this. Really, the main points are that we have build version is parameterized. We pass it to the Go build tool, and it will spit out a version, a compiled binary with the version being assigned to that global variable for use in other use cases. Cool. So now we have the ability to version, we have a make file, but we still really aren't doing anything interesting. So let's make something executable. And we're going to create an API package in our command directory, and we'll call it main.go as our entry point. Cool. Great. So now we have func main, and wow, that was a whole ton of work. We better check that in. You know, it's lunchtime, metaphorically. So what are we going to do? This will consider a task, and we'll say setup version in our builds. Great. So I have Versioner installed on my Mac, but first we'll look. If we look at our Git history, oops, sorry. Prettyify it with one line. Oh, hey. Can't type, or I can, it's just that E is sticking. Great. The initial commit from GitLab, and you can see here we have task, and the fix on our GitLab file, courtesy of my colleague here, Renee. And effectively, this is what our Git history looks like. So if we were to run Versioner, it simply now says, great, you're at 004. Awesome. So what's cool about this? Now, we as a team just need to focus on what is in our commits and the quality of our code in our commits. Excellent. So let's take use of what we're starting here. And one critical component to any application known to improve performance and usability by orders of magnitude is, of course, an application banner with ASCII art. So we'll drop that in and clean it up a little bit Of course, this, I can smell the IPO already. Awesome. And of course, it wouldn't be much just to have it sitting in the binary. So let's print that guy on application start. And of course, we don't want to forget about our version. Awesome. Let's commit that. Task, add super cool banner. Great. So let's check versioner. Awesome. We're at 005. And if we were to now run our make tools, make build using our build version parameter, more or less, we can then invoke versioner, run this. What this will do now is spit out a compiled version in our build directory. You may be asking, why is it a hidden directory? We at Team Mirage try to keep our source code in normal packages and CI/CD non-related source code in hidden directories. And within that, if we were to now execute that, great. We can see Textify super loud and proud on the screen at 005. Awesome. So let's just be a little bit more useful though with this. Of course, just printing this isn't a super useful API. So let's add a handler. Yes. And we'll just handle requests to the root. Awesome. And of course, as a good API designer, we should respond with a super relevant HTTP status code, teapot in this case. And we will respond to that writer. Textify says, and you guessed it, say hello, devox. Awesome. So now we have a handler. And of course, that handler isn't doing much without listening. But we have, oh boy, I'm going to hard code a port. What's about to happen here? Cool. Well, that was quite a lot of progress. So let's add that. Add API handler. Super cool. Versioner still in sync. Awesome. 006. Great. And of course, the last touch we need to this, in the spirit of developing a 12-factor application, we need to let the port be configurable. So using the handy-dandy go flag package, we'll just assign the port to flag P, not 0, P of course, and we'll default this to 8080 here. Use this to configure the port. Awesome. Flag, parse, boom, greatness. Add this final one, and I think this is totally worthy of a feature now. So we'll add this. Oh, haha, very, very, very well, good observation, and quite negligent on my behalf. I was so excited to add this conventional commit, you know what I mean? That's the problem with conventional commits. You just get super hype, you forget to finish the code. Great. Now we're actually using the port. Git commit. Yes, not versioner. We'll use git. In this case, we have a feature, API. The API is serving on the root. Awesome. Now if we run our make build, great, you can see that versioner has now applied 010, and we're able to run this build in its compiled form. We'll spin it up. Awesome. Textify is running. Mac is warning me that some malicious web server is running locally, and we can check it out. Great. We have a running web server. That's, well, we can improve the test coverage here, of course, but for the sake of time and examples, you get the picture. And awesome, this was quite simple, so this becomes quite simple to automate. So we head back out to our GitLab file. We'll build our artifacts. artifacts, of course. Now we need to add another stage, so we'll add a build stage. And of course, apply the stage as build. And then our script will simply invoke our make build version. And as you recall, this will be running inside of the context of a Docker image in the GitLab runner. I've already pre-packaged versioner in the Go builder, so that's what will make that tool accessible. Great. And of course, we don't want to just build the binary and throw it into the ether. So we have the option to set an artifacts directory, which then GitLab can reuse later. And we'll specify that in our build directory. Last modification here is, of course, add that to our GitLab file. I mean, our gitignore. Cool. So we'll add this, git commit. In this case, we'll use a build prefix, update the pipelines with a build. Oh, cool. So I could continue this. I am running a little bit short on time, so we're going to keep moving forward. But as you can imagine, going back to the presentation, the whole point of this exercise, and of course these were quite trivial examples, were that as a team, you need to define your way of working, and then once you have a good definition of it, automate these things, make them repeatable, make them something that you don't have to think about. The same thing goes for deployment. I'll continue to my summary slide. This also, the interesting thing, the benefit of using conventional commits in this way is it improves the comprehensibility of the entire history of a project. I don't know if any of you in the room have been forced to try to figure out what happened in the history of some giant Git tree, but flattening and using conventional commit messages not only make them human readable, but as an example using versioner, machine readable. Builds are now meaningful. They provide clarity and compatibility around upgrade paths. And we're not over here arguing, I really think it's version 2, man. No, dude, it's totally version 3. No, it's really like 2.4, but it's really an alpha release. No, we use commit messages, and we release them, and we let the tools take care of the rest. When we get into deployments, okay, way of working. So the way we work at Team Mirage is with Git flow. And of course, you're probably thinking, oh man, is this dude about to get, he's just like typing in YAML files, now he's going to give us a rundown on Git flow? No, we're not going to go all the way there. But we try to keep it simple. Our developers work in feature branches. The feature branches then merge into a develop branch, trigger a staging release. Production releases are triggered on a merge to master. And I did have kind of a demo prepared for that, but again, due to time constraints, we'll keep things moving. So boom, we're deployed, we're in Kubernetes. Awesome. Great, what's the summary of this portion of the talk then? We're taking versioning, testing, configuring releases, building, and deployments, and we're compressing it into just writing and committing quality code. And there's a lot to be gained from that notion. There's a lot of power there. As you can see, there's a lot of fumbling through YAML, forgetting some dots before a GitLab file that goes into setting this stuff up. But within a reasonable amount of time, you can automate workflows to support your team to just focus on the value add of moving your product features forward. So it's not just about automating things, although I guess it basically all is about automating things in software. So how do we do that at scale with Team Mirage? And we have an interesting scenario because our system deals with really, really high load, but in very, very spiky intervals. So we have some suppliers who are just like, hey, here's all my pictures for today. And then everyone goes to lunch. And then after lunch, everyone's like, oh my God, I need to fix all my pictures I just gave you. And we're talking, this happens in these crazy spikes. So how can we build a system that can handle this kind of large but also spiky load? Meanwhile, we have business like, man, we really got to do AI search, man. I'm like, yeah, totally. I have 15 million images getting thrown at my face right now. So 1 second. So, how can we also move the business proposition forward as well? And you guessed it. Not to be buzzworthy, but we did end up picking a microservice architecture with Kubernetes and using a lot of cloud-native components in Google. Here's a very, very watered-down example of what we're working with. We basically have an API gateway that all of our internal services at Bowl.com deal with us, and then we have a dedicated, because the web shop is super special, a dedicated API for them. But internally, we have all these different services that are managed by Kubernetes. And what does this enable us to do? It allows us to say, hey, all clients, like, if you wanted to do something with rendering, or you wanted to do something with some kind of image processing, or apply machine learning to see about visual duplicates, they just interface with us through a single API gateway. Not anything revolutionary. That's kind of the simplicity of it. And then behind the scenes, we can have all of our services independently deployed, scheduled and organized by Kubernetes in such a way that it can allow us to then scale as needed when logical components of the application come under load. So for example, our storage service, which gets quite busy, it comes under load. We're able to auto scale. And then during those spiky moments right after lunch, and then scale that down. How does this impact sustainable innovation? Well, it's pretty cool because, again, as I said, we have one product one product owner and 4 engineers. So the cloud manages the heavy lifting from our infrastructure. We literally are autonomous as a team. We can deploy to Google, I guess we obviously have a dependency on the cloud, and there's a lot of discussion and a lot of really interesting talks that have happened this week about resiliency. And I don't mean to glaze over those things by any means, but it does from a small team, we're able to leverage all the heavy lifting that Google does for us. Services that can also be added and modified in isolation, of course, as long as their internal APIs are stable. Logical components can auto-scale independently, and of course, clients and users have a single point of access into our platform. That said, microservices are complex. So again, okay, we're dealing with something complex, but we're also trying to deal with something sustainable. How can we deal with microservices in a sane way? So one thing we've done is we actually work in a large mono repository. And that mono repository allows us to effectively test code simply, share code simply, version it easy, and then actually deploy all of these things as microservices managed by Kubernetes. Also, the tooling itself, one thing that I kind of hinted at, but using the Docker workflows in GitLab, we actually mount that Docker image. We mount our workspaces to that Docker image. So all developers have the same tooling that we're actually building our final applications with at their workspace. In terms of some design patterns at the service level, we go hardcore with the onion. And the primary reason there is microservices are complex and observability is important. And thus, if you're mixing business logic with all of the things that you really need to see how your application is performing and communicating with itself in the platform, things can get messy quickly. So our business logic has no logging, has no metrics. It's effectively an interface that then, of course, is wrapped using, as people may refer to as a middleware pattern or decorator pattern, within our service-related metrics. And then application logging is on another layer outside of that, and then so on and so forth. The other layers, some services have, some don't, depending, but they all have a transport. And what this allows us to do is swap out these components if we're going to be serving over gRPC, or if we're going to be serving over REST. It enables the code to be very composable. It also enables us to switch if Prometheus really isn't working, and actually Prometheus is amazing, so it's pretty cool. But in case it didn't, we now have the ability to decouple ourselves from other tooling that provide us observability. And observability is critical in microservices. And kind of the cool, Zen state of observability in microservices, at least that I've observed and seen, is this kind of triangulation of metrics, tracing, and logging. Metrics and logging are probably concepts we're all quite familiar with. Tracing sometimes is less talked about, and I think it's super critical. And effectively, what is this? This is a trace. And what are these things? These are spans. And what are these spans articulating? That from the beginning of that span here, we had some messages endpoint. And then, of course, these are different events that occurred across the system. And what this enables us to do is then actually see where things are going. If a developer were to come on board, we can now actually automate documentation around what services are talking to each other. More importantly, when things start to get slow and things start to get weird, we're not just limited to the internal metrics that we discussed in that onion diagram. We're able to leverage tracing and see the whole system as a whole. How does this impact sustainable innovation? Well, again, going to the top of this segment, single code base. So we're going super mono on the workload side, and then super micro on the runtime side, and that just reduces the cognitive overload of having to manage multiple Git repositories and have Maven do this, and then Go do this, and have JavaScript do this. It allows us to then work in a single repository. Things become easier to test, and code is centralized. Each service, and then in terms of I think the benefits of the observability point of the discussion are quite obvious, but cannot be undervalued. And then with the onion architecture approach, the structure of the code is similar and predictable. Service-to-service communication. This is one thing that also is quite important in a microservice environment. And the key here, at least that we found, is we want to spend less time on how these things are talking, but more about, what they're saying. And what does that mean? Well, we use gRPC, and this is actually pulled straight from the website, so feel free to look at the marketing documentation there. But the reason we like gRPC, going back to this concept of spending less time on how our services talk, but more about what they're communicating, is the ability to, with gRPC, define protocol buffers, define contracts, and then let the gRPC tooling generate clients for us, generate the interfaces that we have to implement, reducing the amount of work that we need to do to actually bootstrap communication between these things. One of the interesting things we found out with gRPC, side note, and many of you are probably familiar with this interesting problem in Kubernetes, but it's HTTP2 load balancing. And the problem is with HTTP2 load balancing, when you're in Kubernetes, the native load balancer is an HTTP1 load balancer. HTTP2 multiplexes multiple requests over a single physical connection. So what you end up having, and we found this out early on in the development of this platform, we got our gRPC stuff set up, we got everything happening, and we just started firing away, and we realized one pod was getting traffic in the cluster. And we found that because it was an HTTP2 connection, the load balancer would receive it, see it as one connection, continue forwarding traffic to the same guy. So how did we solve this problem? Well, there's a couple ways to do it. Fortunately, the Go teams around gRPC have released client-side load balancing, but the other option is to use a sidecar or some kind of intermediary HTTP2 proxy that can actually handle the protocol correctly. But we ended up going with client-side load balancing because back to that overview of our architecture, we're fairly encapsulated. And it's pretty cool because we actually use the Kubernetes API to resolve IP addresses, and we don't have to actually spin up any other infrastructure. So how does this impact sustainable innovation? Going back to the communication, strongly typed contracts that generate our network handling code. We don't have to worry about that. We just have to worry about the business logic of what we need to communicate. gRPC unto itself, complexity patterns like bidirectional streaming are pretty much a breeze in gRPC. And then in terms of what we ended up doing with the HTTP2 load balancing, we don't need to manage any other additional infrastructure. We can just use client-side load balancing and the native Kubernetes APIs. And one of the last things I want to talk about is code generation. So I kind of hinted at that with gRPC. That's just kind of part of the workflow there. But I really think for a team of 4 developers handling the workloads that we deal with, effectively, when I write code, it better be super interesting. And that also facilitates the whole notion of sustainability. If you have developers who are only writing cool code, you have people who want to work on your product. But now I get into an HR rant, and I really am not qualified to go there. So, code generation. Yeah, it's super cool. Maybe it sounds super dangerous, but in reality, we found a lot of benefits for it. So going back to that diagram, if you remember, we have that API gateway where we leverage a lot of code generation is actually with the Swagger CodeGen projects. There's a project dedicated for Go that's super nice. I think even Kubernetes uses it. A lot of big Go applications in the cloud use it. And then for Java, for Python, for Swift, we use Swagger CodeGen. And it's been awesome because now we do kind of API-first design. Yes, more YAML. I know what you're thinking. But what it allows us to do, design our APIs, and then as we're cutting releases, no one on the team is writing Java clients. No one on the team is writing Python clients. No one on the team is writing whatever client that we need to generate for our other users around bowl.com. Vastly reducing the amount of work to have an up and running and very usable API. And I kind of alluded to this slide just a moment ago, but yes, the whole Insta-client principle is super cool. So that said, there's, obviously I'm talking on all this great stuff, but there is obviously caveats, and one of these things is budget. And what's interesting about going to cloud is now actual cost is a direct engineering problem. You're not just dealing with fixed costs in some data center. It's like we actually can optimize and actually influence the bottom line of our business by running more efficiently. And so really what that comes down to is profile, profile, and profile. So I talked about before observability with metrics and tracing and logging, but this is kind of the fourth dimension, and that's just running profiling. What you see here is actually a pprof dump from a Go application, and you can realize that actually the Google code is using the most resources here. Maybe we weren't using it correctly at the time, ironically, because we're running on Google Cloud. I digress. But anyway, profiling and measuring how it actually, runtime efficiency now actually affects cost. So we're really running out of time here. But the last things, and of course it's going to be like, oh man, this dude just glazed over all of the really hard parts. And yes, I admit it, I am. But the reality is there's a lot of other interesting things that facilitate sustainable innovation. And there's been a lot of greater minds, even this week, that have talked about these things like high availability, retry mechanisms, application restarts, data loss mitigation, portability, and security. Sorry for glazing over them, but definitely a critical component, something that we take very seriously in Team Mirage. So, in summary, looking at sustainable innovation, how does that work at Bull.com? Teams are autonomous, and of course, teams can't be autonomous without the right tooling and the right way of working within them to support the greater picture. We at Team Mirage leverage Google Cloud, GitLab, Kubernetes, a whole bunch of other goodies that you just saw. So in conclusion, I really want to just, if anything, leave with this notion of there's a lot of really great approaches to software, but I think we really need to start looking at, or at least Team Mirage has been looking at, what this means to be sustainable, and that's creating and improving a core value proposition without regression in a way that is maintainable in the context of this ever-dynamic business world we work in. Great. Thank you.